This is going to be a video to help us get through SLT 3 using the symmetry of a circle to find angles that have equivalent sine values. First thing I would like you to do is please turn to page 18, pause the video, and use a little bit of right triangle trigonometry to calculate the length of the legs on the triangle. The beginning of this warm-up is calculator active. At this point, you should have tried this on your own, and you should have realized that you are given an obtuse angle of 125. And because the angle of the triangle between the terminal ray and the x-axis should add up to 180 with 125, we know that this angle is going to be 55 degrees. Again, this is our reference angle. So we can set up a ratio, and you might be asking, well, we don't know any sides of the triangle, but oh, we do. Right here, we can see that the radius of the circle is 3, and that means that the hypotenuse is 3. So we can say sine of 55 equals y over 3. And we can use our calculator, and we can type in 3 sine 55, multiply both sides by 3, and we get that y is 2.4, to say how to round, we'll just go to 3 decimal places, AP standard. Okay, we are going to set up a similar ratio for cosine. We're going to say the cosine of 55 degrees is x over 3. And in our calculator, we'll type in 3 cosine 55, and we get 1.72. Now, the directions ask for the ordered pair of the blue point. Now, the ordered pair is not just going to be 1.721 and 2.457, because the ordered pair goes to the left. So if we are going left, it means that that x value is going to be a negative value. So the ordered pair is negative, oh, I went 2 decimal places, negative 1.72 and positive 2.46. Now, what this is going to do is this is going to now introduce us to the idea that different angles can have the same or opposite sine values. So, for example, if we type in our calculator the sine of 55, we get 0.819. If we type the sine of 125, we also get 0.819. Pause the video to type those in and confirm that the numbers are the same. Now, it's important to note that these are both positive values. And because they are positive values, we look back at our picture and we're like, oh, well, they're positive because the y value is positive. Ooh, I did not leave myself enough space to write there. Okay, so they're positive because the y is positive, which of course begs the question, what happens if we put our reference angle of 55 degrees in another quadrant, like the third quadrant? If I put 55 here and I connected it to this red terminal ray, ooh, I was almost made it. Okay, now it's 180 plus 55. This angle is actually 235. So on our calculator, let's type in the sine of 235. And we get negative 0.819. Let's also put 55 degrees in. I'm trying to get these to like match up, but if I put 55 here, well, that was pretty good. I'm going to do 360 minus 55. I'm going to get 305. I don't put it there. That looks bad. Okay, let's type in the sine of 305. And if we type in the sine of 305, we also get a negative value. So let's make a note here that here we have terminal rays below the x-axis and we have negative sine values. Okay. So let's take a look at our quadrants. We have 4 quadrants. We have quadrants 1, we have quadrant 2, we have quadrant 3, and we have quadrant 4. So what I want everyone to note at the bottom of the page, in 1 and 2, the y value is positive. So the sine of any angle with a terminal ray in quadrants 1, or in it should be an or really, or 2 will be positive. Okay, I want you to pause the video and I want you to write a very similar sentence dealing with quadrants 3 and 4. Okay, hopefully you wrote, in quadrant 3 and quadrant 4, the y value is negative. So the sine of any angle with a terminal ray in quadrants 3 or 4 will be negative. Okay, what I want to do now is I want to take a look at last night's homework. And last night I asked you not to fill in symmetric angle with the same sine value. So I want you to notice something from page 18. On page 18, 55 and 155 have the same. Well, I never drew in 55. We should draw that in too. Okay, 55 and 125 have the same sine value because both y values are above the x-axis. Okay, and then 235 and 305 have the same sine values because they have the same reference angle and both of their y values are below the x-axis. So now let's take a look at last night's homework and fill it in. Whoops. Okay, so looking at last night's homework, our first angle was in the first quadrant. And you can see in green, I drew another angle in the second quadrant because both of those quadrants have positive y values. So if I find the angle that has the same reference angle as 39 degrees, you can see I did 180 minus 39, so we get 141 degrees. For number 2, we had 125, which fell in the second quadrant. And the reference angle for that was 55. Now, if I just take 55 degrees and I put 55 degrees in the first quadrant, it will have the same sine value because they have the same y values, the same positive y values. Whoop. Number 3, 260 we found had a reference angle of 80 degrees. So what I'm going to do in this purple angle here, I'm going to put an 80-degree reference angle in the fourth quadrant because y is negative in the third, y is negative in the fourth. And then we're going to do 360 minus 80 and get 280. And that will have the same sign as 260. Number 4, our angle 341 was in the fourth quadrant, and I had a reference angle of 19 degrees. You can see here in purple, I've drawn this has a negative y in the third quadrant, so I'll do 180 plus 19 to find that angle, and I get 199. Why don't you pause the video and try the bottom page finding the symmetric angles with the same sine value. You should have tried these 4 problems on your own. Let's take a look at them. 135 is originally in the second quadrant. It has a positive y value, and its reference angle is 45. So it's pretty easy to find another one. I'll just put that reference angle in the first quadrant, and it will have the same positive y value. Number 6, 290, is in the fourth quadrant, and it has a reference angle of 70 degrees. Now, this has a negative y value, so I'm going to jump to the third quadrant where there's also a negative y value. Put 70 degrees here. Now it's going to be 180 plus 70, and we will have 250. Those angles will have the same value, same sine value. All right, 232 has a negative y value and a reference angle of 52 degrees. So I'm going to take that 52-degree angle and drop it in the fourth quadrant where I also have a negative y value. And then to find this angle, I'm going to go 360 minus 52, and I'm going to get 308. And my last one, little 1-degree angle, first quadrant, y is positive. So I'm just going to drop that little angle in the second quadrant, and 180 minus 1 gives us an angle of 179. So that is how we can find symmetric angles that will have the same sine value. Okay, so on page 19, it says using the symmetry of the circle in different quadrants, we can find values of trig functions for angles of more than 90 degrees. So really what's happening here, when we put an angle in standard position, remember standard position, we start on the positive y-axis and we go counterclockwise from yesterday, we can find a reference angle. And that reference angle is measured from the terminal side to the x-axis, always to the x-axis, never to the y-axis. So when I do that, I want to make note of certain values. So you can see I filled in my picture the same as on page 18, but I've drawn all the angles and I've put in all the points. So what I want you to notice is that here in the first quadrant, we have positive, positive. We're going to label this x, y, and this is our radius r. Let's remember, please jot down that the sine of theta is opposite over hypotenuse. In this picture, the opposite side is y, and the hypotenuse is the radius. Cosine of theta is the adjacent side over the hypotenuse, and tangent of theta is opposite over adjacent. Now, I want you to put a little star here and make a note that r is the radius, which is always positive. So when we are looking to determine whether a value is positive or negative, it is not dependent on the radius. The radius is always a positive number. So I want you to look here in the first quadrant, x is positive and y is positive, and r is always positive. So we say that all values are positive. So that means sine, cosine, and tangent are positive. All have positive values. Now, when I jump to the second quadrant, my x value is negative and my y value is positive. Which trig functions rely on x? That's right, cosine and tangent. Sine does not rely on x, so the sine will be a positive value, but cosine and tangent, if the terminal rays in the second quadrant, will be negative values. 1, 2. Now, down here in the third quadrant, we have 2 negative values. X is negative, y is negative. So that means that both sine and cosine will be negative because we're dividing one of these values by our positive radius. So let's write down sine and cosine are negative, but tangent, Because we are dividing y by x, a negative divided by a negative will be a positive value. All right. So here in the fourth quadrant, x is positive, y is negative, sine is dependent on y, it's going to be negative, cosine is dependent on x, it's going to be positive, tangent is the division of y over x, it will also be negative. Okay, so just as a note that you will see again in pre-calculus, we're not going to dwell on it too much because our focus in this unit is going to be on sine, a little bit of cosine and tangent, but mostly sine. In the first quadrant, on a yellow highlighter, in the first quadrant, they are all positive, A for all. In the second quadrant, only the sine is positive, S for sine. In the third quadrant, only the tangent is positive, T for tangent. In the fourth quadrant, cosine is positive. So there's a saying that we do use a lot in pre-calculus called all students take calculus, and it helps us remember what's positive in each quadrant. In the first quadrant, A for all. In the second quadrant, S for students. In the third quadrant, T for tangent. And in the fourth quadrant, C for C for cosine. Okay, now the last thing we are going to jot down here before we do some practice, we want to make some notes. To find symmetric angles, why will it not let me delete? With, and now it won't let me type. With, oh my gosh, guys, why can't it will not let me delete? You know what the solution is, new text box. Otherwise, I'll just handwrite it all. All right, let's try that one more time. Here we go. To find symmetric angles with the same sine value. The first thing we are going to do is we are going to drop the reference angle. Oh, now I can delete. That's nice. In the quadrant with the same y sine. So like if we're starting in the first quadrant, we're going to drop to the second quadrant. If we're in the fourth quadrant, we're going to go to the third quadrant. After that, we are then going to determine the angle in standard position. All right, so once you have that jotted down, I want you to go ahead and do page 21. Sorry, not page 21, page 20. And page 20 is basically the same as last night's homework, but now we're actually going to do the angle with the same sine value. And just for practice, before I end the video, let's take a look at number 3, because number 3 is in the third quadrant. I feel like the first and second quadrant ones are a little easier. So I want everyone to sketch a angle in standard position with a measurement of about 230 degrees. So 230 degrees is going to fall in the third quadrant. Okay. I know this is 180. So I'm looking for the reference angle here between the 180 line and the 230 line. So I'm going to subtract 230 minus 180 and get a reference angle of 50 degrees. Well, while I'm here, I might as well go through all of it. Coterminal angle with a clockwise rotation, so that means a negative angle. And so if this is 50, we could go negative 130. Okay. Now, the symmetric angle with the same sine value, that's kind of in my way. My reference angle is 50 degrees. This is a negative y. So I'm going to go to the other negative y, and I'm going to drop 50 degrees in that quadrant. So now here, that's going to be 360 minus 50. So that's going to be 310 degrees. Go ahead and finish the rest in class. Anything you don't finish is homework.